In this video, we're going to explore more about diagnostics on the foundation Fieldbus system using a simple multimeter. So Jim right now is going to take his meter probes and connect directly across the terminals of a foundation Fieldbus transmitter. And we measure a voltage signal here that is about 320, 330, 340 millivolts AC. Now remember that the foundation Fieldbus signal is a Manchester encoded square wave signal. So the fluke meter over here, which is a true RMS multimeter, is giving us the RMS value of that square wave signal. Recall from basic electronics that the RMS value of a square wave is equal to its peak value. So if we read 330 millivolts, that is the peak value of the square wave. Recall also from foundation Fieldbus system specs that a healthy foundation Fieldbus signal should be between 350 and about 700 millivolts peak to peak. So this meter is giving us roughly half the reading of our peak-to-peak signal. So 330 millivolts on the meter corresponds to 660 millivolts peak-to-peak signal, which is a nice, healthy signal on a Fieldbus system. So we're measuring that between the plus and minus terminals on our transmitter. Now what we're going to do, we're going to check and make sure that we don't have a ground fault in either one of these conductors in the system. So what Jim's going to do is keep one of his probes on the 1 meter screw terminal, take the other probe, move it over here to chassis ground. We happen to have a ground bus conveniently located here in the lab. So he's going to measure that. And what he measures here is about 180, 190 millivolts, maybe up to 200 millivolts. Now Fieldbus systems are supposed to be floating. Neither conductor is grounded. So it's kind of random what the voltage is going to be here, but it's certainly not zero. We're reading about 180, 190, 200 millivolts. Now Jim's going to move his probe to the other terminal and move the red one to ground. There we go. Polarity here really doesn't matter because it's all AC. Notice here from the other terminal to ground, we still measure 180, 190, 200 millivolts, roughly the same. That's what we expect for a floating AC system. If, on the other hand, one of these two conductors in our Fieldbus network were to suffer a ground fault, we would see one of those measurements be far, far lower than the other measurement. One from here to ground would be much closer to zero, and the other from there to ground would be closer to its full 330 millivolts or so. So that's a simple diagnostic test we can do with a true RMS multimeter such as the Fluke. Now to do this, again, you need a high quality multimeter. It may sound like I'm a spokesperson for Fluke here, but Fluke makes a fine product. True RMS is a very good feature to have. You also want to make sure the meter has a high enough bandwidth to be able to measure this. And these Fluke 87 meters and the newer ones have fantastic bandwidth on the AC voltage readings. So they'll read a 31 kilohertz signal, no problem whatsoever. Other cheaper digital multimeters won't do that. They're also fantastic at discriminating between AC and DC, which is important. On the AC setting, I only want to be measuring AC. I want to ignore the DC. Once again, Jim, go back to those terminals. So on a Fieldbus system, I actually have, switching to DC, I actually have about 25 volts DC powering up the instrument. If I switch to AC on the meter, this meter is now going to discriminate and only show me the AC portion of that signal and reject the DC, which is very important for seeing just how much signal I have versus how much DC power. Again, cheaper digital meters won't necessarily do that. They'll kind of give you a jumbled reading that's part AC, part DC in some cases. But the Fluke meters are fantastic in this regard. So again, basic diagnostic tests with the Fluke multimeter, AC, especially locking in the range here. There's my signal strength, about 330 millivolts peak, which is about 660 millivolts peak to peak. Let's do a measurement from one terminal to ground again. Being a floating system, I would expect to see a non-zero reading, and we see one here about 180, 190 millivolts. And then moving that other probe, you can do that, measuring from this side to ground, about the same reading. We see equal readings between either one of these terminals and ground. We're looking at a healthy floating system. If, on the other hand, one of those readings from there to ground is much greater than the other from there to ground, or one of them is all the way down to zero, now we're dealing with a ground fault somewhere in the system on one of our communication lines.